Now we're going to talk about graphs of equation in two variables. Graphs of equation in two variables. So this topic, first we're going to talk about intercept and symmetry. So let's talk about intercept. Right, intercepts. Okay. Well, just to start with the general background, when we say graph of equation in two variable, usually means something like this. You graph y equal x plus 1. Now, something like this, that we call this equation because we have this equal sign, right? Equation, since we have equal sign. And something like this is going to be two variable case because we have this variable y and variable x. So two variables, right? So something mathematical equation that looks like this, that we're going to call that as graph the equation um, with two variables, right? Equation with two variables. So what we trying to do is trying to try to understand the graphs of these type of equations. Now, since we have two variables, this graph exists in two-dimensional world. Well, what's two-dimensional world? Well, two-dimensional world is this flat space, just like this blackboard. So if we have this x-axis and y-axis, something like this equation is going to exist in this coordinate system in this dimension, two-dimensional space. Now, something like this is considered as a linear equation since we have two variables, but the exponent of those two variables are both 1. Now, some case, we might have equation that looks like this. Y equal x squared plus 1. Something like that. Well, this is still equation, is still two variable, but this is not a linear equation. This is a square, so this is going to be non-linear equation. Non-linear equation, right? Non-linear equation. So we are going to deal with couple of simple case for this linear and non-linear equation and their graphs. All right, so I guess one of the example would be something like this. Determine if the following points are on the graph of the equation. And the equation is 2x minus y equal 6. And the first one, let's say a equal 0.2 and 3. All right. So what does that really mean? That means this is the given equation. It has a two variable. See if this point fits in to this equation. Now this first point right there is going to be the x value, and the second point is going to be the y value. So what we are going to do is replace x by 2 and y by 3. So the given equation is going to be 2 times what's supposed to be x, now it's going to be 2, minus what's supposed to be y, now it's 3. And we would like to know whether this is equal to 6. That's 4 minus 3, 6. And we can see this is not the case. Which means what? This point, is it on the graph or not on the graph? This is not on the graph. Alright, not on the graph. Alright, so just replace x and y, see if this equal sign makes sense. If it does, that means it's on the graph. If not, then it's not on the graph. Alright, let's talk about this next point. Let's say 2, negative 2. Again, this is the x value, and this is the y value. So now we have 2 times supposed to be x, now our x is 2, minus y, our y is negative 2. Is this equal to 6? That's 4, this double minus plus 2 equals 6. And check, this is true, right? This is 6, this is 6. So this given point, this is on the graph. Alright, so nothing really special, but that's what we have. And that's what we have. Alright, so this is like a typical setup of equation. See, they give you an equation and typical setup of example, sorry. And they give you an equation and see if that's, the given points fits in. All you need to do is just substitute the point and that's it. Now, next very common question is a, simply graphing question. So let's say example. Graph. Let's say first one is relatively simple, y equal 2x plus 1. Alright, so, just before we jump on and start graphing, just to looking at this equation, we know this is going to be two variable case, right? Because we have x and y. What does two variable means? This is a 2-dimension 2D graph. And this is going to be linear case because we have exponent of y as 1, exponent of x as 1. Linear case, straight line case. So, there are more than one way to graph this, but later on we are going to do a full investigation on how to graph a linear equation. But for now, let's settle with this table technique. So x and y. Now think about it. How many points do you actually need to figure out a straight line? Well, technically it's just 2, right? Think about it. If you have like this point and this point, now you can figure out the straight line that passing through those two. So technically what we need is just a 2 point. But, let's just use 3 when x equal negative 2, when x equals 0, and x equal 2. Now, is there any particular reason that I choose these 3 numbers? Well, not really. But is this the usual number that they use? That's true, right? They usually use, couple of negative, couple of positive, and probably 0, right? So what that means, I'm going to put this value in place of x right there, and then see what y value that we're going to get. So if I replace this by -2, 2 times -2, that's -4, plus 1, so that should be -3, right? If you put -2 there, you know that's 2 times -2, which is -4, plus 1, -3. If I put 0 there, 2 times 0 is just a 0, plus 1, so y is just going to be 1. If I put 2 here, 2 times 2, 4, plus 1, 5. Alright, so, you know, given these 3 points, let's try to graph this. It's not really straight. Okay, a little better. So, -2, +2, that's a 0. This is x side, this is the y. So when we have -2, y is going to be 1, 2, 3, -3. So we have this point, right? When x equal -2, y is going to be -3. This is the point. When x equals 0, y is going to be 1. Right there. That's another point. When x equals 2, y is going to be 5. So 1, 2, 3, 4, 5 should be about here. This should be a little bit longer. So it's about here. Let's say that's 5. So now we have these 3 points. All we really need to do is just connect this with, let's try again, connect this with a straight line. Right, let's pretend that this is a straight line. Right, connect this with a straight line like that. So when we have this table, transfer this table into a point and connect it with a straight line. And do we have to use the x first and figure out the y second? Answer is yes. Do we always do it like that? Answer is almost always. Right? There's a minor exception, but we'll talk about it when we get that type of example later. Okay, so let's try just one more example. Let's say we have y equal x squared. Now, this is nonlinear. How do I know? Because of this 2. So we know we are expecting some type of curve. So let's build our table. But let's say it's difficult to a straight line. Let's say this is x value, this is y value. Let's do -2, -1, 0, 1, and 2. Let's do 5 points. Right, let's do 5 points. Okay, so when x equals -2, what's y gonna be? So when I put -2 in place of x, we have x negative, when we put -2 in place of x, -2 squared, -2 times -2, which is 4. When I put -1, -1 squared is 1. When I put 0, it's going to be 0. When x equals 1, 1 squared is 1. 2 squared is 4. So we have these 5 pairs, right? 1, 2, 3, 4, 5. 5 pairs, right? Okay, so let's try to graph this. So this is y, this is x. So -2, -1, 0, 1, and 2. When x equal -2, y is going to be 4, so it'll be 2 and 4. Let's say 4 is here, this point. When x equal -1, it's going to be 1. So it's 1, 2, 3, right? Then it's going to be 1. When 0, 0, right there, 1, 1, 2, 4, 2, 4. I mean, now what we're going to do, we are not going to connect these points with a straight line because we're looking at the non-linear equation. So we're going to try to connect with the curve. So smooth continuous curve. Just like that, right? Okay, so there we have it. This is the curve that the graph of this equation. Okay.